NFA. Now this NFA is represented by this. See here, PQRS. Very first thing is representing your what? The state, that is Q. Second, this is representing your summation. This is delta function, which is nothing but this one, right? And P is representing your Q0, that is initial state, and this S is representing your final state. So I hope you have understood that this is your given NFA, which is represented by M. Now it is asked to convert. Problem is convert the NFA, which is represented like this, to equivalent DFA, where STF delta is shown below. So this STF is shown. Without this, you cannot understand what is the working of NFA. Now we want to convert this particular NFA to DFA. So when we have to convert this NFA to DFA, what we need to do? We need to prepare. So how many states, possible states will be there? See, now I am trying to solve this problem. So in M, you are having Q summation, that is alphabet, delta, Q0 and F, where here Q is having how many states? 4 states, right? See, 1, 2, 3, 4, and F is also having only one state. See, S is your final state, right? So here in F you are having one state. Now we want to convert this to equivalent DFA. So you will be having, yesterday we have discussed, where will be the change? There will be change in Q, delta and the F. So if we are able to find out these three things, then we will say that we have converted given NFA to DFA, right? So now how we are converting? For conversion, we will apply the same thing. Okay, so yesterday we have discussed direct and indirect method. So using direct method, what we need to do is we have to prepare a table. Okay, and in this table, how many states will be there possible? Yes, now tell me orally. What is your Q here? Your Q is 4 states. So in equivalent Q dash, you will be having what possible states as q raised to the power q, which will be 2 raised to the power 4, right? So this possible combination states are possible. So 2 raised to the power is 4 is nothing but 16, right? So here you can have 16 states. So we will very first list out all those 16 states. Okay, so we will start from P, Q, R, S. Okay, 4 states are over. Next, we have to do combination, two combinations. So two combinations will be PQ, PR, and PS. So the turn with this is over. Now we have to consider these 3 states. So it will be QR, QS, right? Next, RS. Okay, so let me number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Next, now we have to consider 3 combination. So 3 combination will be PQR. You have already learnt all these things in discrete mathematics, like PQR, then PQS. Right? Any more combination? QRS. Right? Next, any more combinations possible? Anything is remaining? Just tell me. PQRS, PQ, PR, PS, QR, QS, and RS. Then PQR, PQS, QRS. Next, So it will be 11, 12, 13. One state is missing because 15th will be your PQRS. So which state is missing? Or numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So which state is missing here? Yeah.
SPR.
Huh?
SPR.
See, you're not audible, please. Hello? Which is missing?
SPR.
SPR, PRS. Okay. PQR, PRS. Yes, I have not written. PRS is missing. Yes. So 14th will be so PRS, right? And then so let me make this as PRS and this as a QRS. Okay, so now how many states are there? 15 states will be there, right? And we will be having now the entries in this table, okay, for 0 and 1. So now you can easily do entries. So very first I need to copy this rows. It will be PQ, P, R, R, S, dash, S, S, right? Next, PQ, that means I need to do union of this. So you just tell me PQR, then combination of PQ, PR, right? Then next is PR. So I need to do combination of this and this. So PQS. Next, P only. Next, PS will be PQS, PS, right? Next, QR, RS, R. Then QS, QS will be RS. Then RS, right? Next, RS will be S. This will be also S. Next, PQR. So PQR, we have to do combination of this. Okay, so it will become PQRS and again PR, right? Then PQS, PQS, PQ and S. So it will be again PQRS, PQ and S. It will be PRS, right? You can make me correct. You can tell me the corrections, right? Next, PRS, PRS. So PQS and PR and S. It will be PS. Next, QRS, QRS, RS, QRS, QRS. It will be again RS. And finally, PQRS, combination of all this. So it will be PQRS and it will be PRS. I hope everyone understood the initial generation of delta for corresponding DFA. So it will be a delta dash. Now today we will be learning about some new concept. See, if you will see this particular and if you will draw 15 states, okay, we'll be having a big DFA and that will be having some kind of redundancy or repetition. So here the concept of minimization we will be learning. So what is the concept of minimization? So the concept of minimization is you have to, as it says, minimization. So you can do minimization of any DFA if it is having certain types of scenario. So very first scenario is what? You are having some, you have to remove the equivalent states. Now what do you mean by equivalence of a state? So yesterday I have told you, when we are having, see, for example here, if you will see this, these two rows, row number 12 and row number 15. For state PQS and PQRS, we are having same entry. That means same next states. Which next states? PQS on 0 goes to PQRS and PQS on 1 goes to PRS state, right? Similarly, PQRS state on 0 goes to same PQRS, same. And here on 1, so it is necessary this whole combination must be there. Okay. So if such combination, second thing, when you are trying to tell that the equivalent states, then it is necessary the both states, this side states, left hand side state, they must be either both non-final state or both should be final state. If they are of same type, then and then only you will say that it is equivalent. So let us check, this is okay, they are same. But what about this? So let us check PQS, it is having S. So it is a final state, right? Similarly, PQRS is also having S, right? So this is also final state. So this criteria is also satisfied. So what is the criteria? The left hand side, that is the state, must be both either non-final state or either they should be final state. So since both are final state, they are having same next combination of states, next states. So we can say that PQS is equivalent to PQRS. Okay, and what we will do, we will remove the equivalent states. Okay, so actually since these are equivalent, there is no need of such state. So what we will do, we will remove this particular row from the DFA. Once we remove this DFA, this state, that means in a final DFA, instead of now 15 state, you have only the 14 state. So likewise, we have to check it for each and every state whether any kind of equivalence is existing among the states or not. If it is existing, then we have to minimize the number of states. So I hope the concept is clear. What is the equivalence of state? Equivalence of a state, or so very first in minimization, what we do? We find out the equivalent states and we minimize the equivalent state. Second, if you are having any unreachable state, what do you mean by unreachable state? So, the meaning of unreachable state is, suppose I am having any initial state Q0 and then I am having some final state here Q1. So I can say that Q1 is reachable from Q0, which is a initial state. Okay. Now suppose I am having any other state, for example, Q2 here. Now I can say that I am not reachable to Q1 from Q0. Q2 is reachable from initial state. Okay. Now similarly, what is the meaning of unreachable state? If you are having any network break, that means suppose again there is a Q3 state and there is a final state Q4. Okay. Now this all are part of same DFA. Huh? Now the question may be how it is possible you can have such kind of structure. Yes, it will be there. In the same example you will experience. Now see, from this initial state I'm not reachable to Q3 state. If I'm not reachable to Q3 state, so whether it is reaching to final state or not, it doesn't matter. So there is actually break between the network starting from the initial state. Okay, so such break or such unreachable state should also be what avoided. They will not be the part of a final DFA. Okay, so all such states which are Q4 is not also reachable from Q0. Have you understood? So Q4 and Q3 are not reachable from initial state, hence they are actually showing the network break from initial state, and hence this whole part will be unreachable from initial state and it should be minimized, it should be cut. So when you have drawn DFA, suppose you got Q0, Q1, Q2, Q3, Q4, 5 states. But when you will draw final DFA for this, you will not include these states. So I hope this concept is also clear. Next, third is a trap states. So what is the meaning of trap states? The meaning, as it's, I have also discussed this in last one lecture. So as its name suggests, trapping. You are not able to reach to anywhere from this Q2. Once you reach Q2, there is no path available, okay, to move ahead to reach the final state or any state. Okay, so we can say that this Q2 is a trap state. Once you go here, you are not able to move anywhere. Okay, so such state should also be avoided. They should be also minimized. They should be also cut down. So from this example, what we can say that when we have converted, suppose NFA to DFA, or even if this is a simple DFA, for example, then what will be your final minimized DFA? Final minimized DFA will be having only and only how many states? The two state, that is Q0, Q1, where this unreachable state and trap states as well as the equivalent states. All these states should be cut down, they should be minimized, and whatever will be the remaining thing will be called as your final DFA, minimized DFA. So the concept is clear. Concept is clear to everyone. What is the meaning of minimization and what we should do? So we should do what? We should try to minimize the given DFA by removing the equivalent state, removing the unreachable state, and removing the trap state. So in this example, already some worked out things are there. So I'm just showing you, but you have to work out at your level. See, I have shown you these 15 states. I have also discussed with you how to find out the equivalence. Now, here I am presenting already worked out example. Okay, will it be okay, or I should work out once again? I don't have any problem in that. What do you want? Tell me. Would you like to work it out once again, or from this you will be able to understand? Should I work out? Okay. So let us go ahead. So we are now working out. So I'll take the same picture and we will start working on it. So with different colors. So we will start from this. Let me make this bigger one. Okay, so we will start with this. So let us first mark all final states. So this is your final state. This is your final state. Okay, mark everyone your final states. This is your final state. This is your final state. This is your final state. This, and this. So now how many final states are there? 1, 2, 3, 4, 5, 6, 7, 8. I think in your example, in your working also, the same thing is there. So now, very first we will check the equivalent states. So PQ and P, this combination do you find anywhere? PQP, 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 PQP? No. So it is the individual state. P must be there. This is your initial state. Let me mark. Okay, now second row, R, R. Anywhere you are finding R, nowhere. So this is also required. Next, S dash. So again, S dash not. This is also required. Next, SS. Yes, we are finding same combination as S here. Anywhere else? No. So we are finding that this combination is available at this particular position. Okay. But as I have told you, we have to check this side also, right? Now, if both are same type means if both are final or both are non-final. Since both are final state, see S star star. Okay, so we can say that here very first S is equivalent to RS. Understood? Second. So what we will do, since this is equivalent, we will cut down this row. As soon as we cut down this row, now what will be the problem? The problem will be, since RS is included in this side, we have to replace all the RS with the equivalent state S. So here, we have to very first search for RS. Where is RS? This is RS. So now this RS will be becoming S. Right? Similarly, this RS will be now S. This RS will become S. Got it? Anywhere again RS is there? Yes, here it is RS. It is S. Again it is S. So all the RS should be replaced by the S in this table. Got it? Now, again, so we have kept what? S. But we have removed the RS row. Okay. Next, we are moving next row. PQR and PR combination we want to see whether there is anywhere PQR PR combination, PQR PR nowhere. So we need to keep this as one. Next, PQS and P. So PQS and P, PQS and P. Nowhere it is there. It is PQS and PS. So PR is PQS and P, right? So again, you can see that you are having no such equivalence for this state. It will be included. Next, PQS and PS. Yes, somewhere we have seen. Yes, PQS and PS. Okay, so this is there. So we can see that this particular combination PQS and this PQS PS is repeating, right? If this is repeating, we need to check the left hand side. Now check the left hand side and what you will find, you'll see that the states, this is having S, this is having both are star mark. Okay, that means both are the final states. So we can declare that PS is equivalent to what? PRS. Understood? So now we have to replace once again all the entries for PRS in the right hand side. So very first we will remove this row not included, and now we have to check where the PRS is available here. PRS, 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 yeah. Here we have identified PRS. So this PRS must be replaced by PS. Okay. Anywhere else? Yes. This already we have cut down, but if you want this should be considered, then it will be same and it is going to be cut down, right? We are assuming it is not yet cut down. We are going serially. Okay. So these two places we have find out PRS and we have replaced it by PS. Okay. Next. So finally what we have decided, we need to keep PS and we have to minimize this PRS. Again, we are moving ahead now. SR. This combination SR, SR, SR. Nowhere, or we can say RS. 1 minute. Where we are? Yeah, SR. SR, 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 nowhere. So we need to keep this as it is. Is it correct? 2R. Yes. Right. Next, we have to check SS. Whether it is available. Yes, it is available here. So SS, SS. Anywhere else it is available? Yeah, it is available here as well. Okay. So three places we have identified the what? SS. So what we can say here? What is equivalent? Once again, S is equivalent to, where it is? QS. Right? S is equivalent to QS. So the state number 9, that is also going to be minimized, right? So here again we have to check the left hand side. Is it final state? Yes, it is final state. This is also final state. So what we can do? We can do what? We can minimize this. We can also check that QRS. QS is also equivalent to QRS. See here also you are finding the same entry. So S is equivalent to QS, QS is also equivalent. So these three are equivalent. So what we can do? We have to check whether this QS and QRS, where it is? Yes, this QRS and this QS both are also final state and they are equivalent to what? The QS state. Okay. So we need to cut down state number again 9, right? We can replace this with, so QS and QRS. Okay. All are equivalent. So all will be minimized, replacing what? What we have to replace? All the QS must be replaced by S. So again we will search anywhere we are finding QS, 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 nowhere, right? Similarly, we have identified equivalence with QRS. So QRS, anywhere we are finding QRS, 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 nowhere we are finding the QRS, right? So Finally, what we can do, there is no replacement for this QRS. Can anybody see any place QRS is available? I think it is not available, so we will just simply cut it down because all are the final states. Okay, so finally, what is concluded? We were talking about, sorry, QS and QRS. So QS we have already checked and QRS also checked. So this is no more in this uh, table. Then RS is already cut down. Next is the PQR, right? So PQR is having entry as PQRS and PR. So see PQRS and PR entry, so it is not there. PQRS and PS is there. Then these two are cut down, PQRS and PS. Yes, we have identified these two same entries, right? So we can say PQS is equivalent to PQRS, right? So since both are equivalent, we have to replace all PQRS with the PQS and remove this row. So this row is removed and you will be replacing PQRS by what? PQR, right? Here also I have to replace PQR, all the entries, right? So now what is the case? This PQR will be having PQR and PR as entry. Am I right? And PQS is having entry as PQR and PS, right? Now everything is over. This is already cut down. This is also cut down, and this is also cut down. So finally, see how many states are the PQR we need to consider because we have just kept it. So how many states are there? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so there will be 9 states in the table. So we will finally draw this simplified or equivalent diagram. Okay, so it will be having Q summation and will do the entry Q, and there is a 0 and 1. So which states are remaining? P, Q, see whatever I take, I'm taking that only. R, S, right? Next we have to consider PQ. Is it visible? Yes. Then PR is also there. I need to keep it. Next, PS is also there. Next, QR is there. Next, PQR is there. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So their numbers were 1, 2, 3, 4, then 5, then 6, 5, 6, 7, then 8, and finally the 11. Okay, so let me check. Add also same number of states. So P, Q, R, S, P, Q. PR, PS, QR, and PQR, right? So these were the original numbers, right? And in total, how many states are there? There are 1, 2, 3, 4, 5, 6, 7, 8, and 9 states, right? And now I'll just make all the entries as it is: PQ, P, R, R, S, and S. Then PQR, sorry, PQR, PR, PQS, P, then PQS and PS. See, PQS, we have not replaced this PQS. PQS was equivalent to PQRS. No, so it will be there. No? Is it included? PQS? Then anything is wrong? PQR and PS. So we have to keep this also, no? How many states are there? PQS is missing. There will be again PQS we have not included. See, this is there. We have replaced this PQRS by PQS. So PQS will be there. So we need one more entry. PQS is having which entry? 12 number entry. So PQS. You can make me, you can tell me the correction. Okay. So now, and it is must as it is here. Okay. So then 7 is there. PQS, PS. Then 8 is SR, then PQR. PQR is having PQR and PR, and finally PQS is having PQR and RS, right? So total 10 states you got, right? And these are the original numbers. Okay. Now we are trying to draw the states from this. Anywhere again you are finding any equivalence, just check once again. Any, see, again we are finding here one kind of equivalence. Is it? See, this PQR, this is also there in this PQR. Okay. Now we will check. Yes, any problem? Now we will check the left hand side. Again we will check this left hand side. PQR we have kept it here. PQR, PR and PQR, PR. Right. So here also we could have the equivalent, but it's okay. We could not find there.
Yes.
Yes.
So
Yes.
lastly, we have written that PQS is equivalent to PQRS.
Yes.
Then you have written in the table PQR.
Yes. Yes. So
So means 11 number there should be PQS now.
11 number, see here, 11 number is PQR. It is having entry as PQRS, PQR and PR.
But PQRS is equivalent to PQS and you have written PQR.
Acha, acha. Here the mistake is there. Okay. Right. So PQS is equivalent to PQRS. So we need to include this. So all PQRS will be replaced. Yes. it will be PQS, right? Now
Yes, ma'am. Yes, now it's correct.
it is PQS and PR. So let me write it here also. Uh, 11 number, it will be PQS, right? So PQ, no, sorry, it is PQR. Here it will be PQS, right now. So now PQS and PR. And here, okay, so now the equivalence will be of PQ and PQS. Will it be okay now? Yes. Thank you. See this kind of CR entries PQR and PR. It is PQS and PR and it is PQR and RS. So finally, there is no equivalence. Whether there will be equivalence or not. So PQRS, PQPRPS, QR and PQR and QR and RS. Something is going wrong.
Ma'am, in 12th entry also it will be PQS.
1 minute. This is 12th entry. Yes, correct. So let me make it as again S. Okay. So now see once again. 1 minute. Let me check once again. This PQS, PQS. This is also PQS, right? And we have made equivalence of PQS and PS, PQRS, and we have replaced this PQRS with PQS, right? Now we have entry PQS and PS. So PQS and PS entry is also there. So we have replaced this PQS again by the PS. This will become PS now. Are you getting? Okay, let me make here simply. Till what we have reached? PQ, PRR, SS, SS, PQR, PR, PQS, P, PQS, P, PQS for PR it is PQSP, for PS it is PQS and PS, right? For 8 it is SR. Then for PQR we have PQS and PR, and then finally for PQS we had, which we have already removed na, PQS, PQRS and PRS, no, we have included, so it will be PQS and PS, it is PS, right? Now see once again, now it is correct. Check once again. See, for PQS, PQRS, PQS and PS entries there. I have written here PR. So PQS, PQS, PS. Right? Now once again we will check PQR, PR is not there. So this is not there. This is okay, this is okay, this is okay, this is okay, and this is okay. PQSP is not there, PQSPS. So PQSPS is there. Yes. So PQSPS is there. So it is equivalent to this. Okay. So PS is equivalent to PQS. Right? Now we will check here these two. Both are the final states. Okay. So we can replace all PQS by PS once again. And now finally our table will be having again, we don't require, or there will be no such state, and every PQS will be replaced by PS. So this will be replaced by now PS. This will be replaced by PS. Right? Okay now. So now finally, how many states are remaining? 9 states. Which are those? P, Q, R, S, P, Q, P, R, P, S, Q, R, and P, Q, R. P, Q, S is not there at all. So that's why here, yeah, this P, Q, S will also be replaced. You should tell me. This P, Q, S will be also replaced by P, S. So finally, we have got which states? P, R, P, S, S, R, and PQR. I think there is no equivalence remaining now. PQP nowhere, RR nowhere, SS, SS, PQR, PR nowhere, then PSP, 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 PSP nowhere, PSPS nowhere, SR nowhere, PSPR nowhere. So all are the unique states, right? Now we will draw the diagram for this and finally conclude our this figure or this. So let me start with the initial state. This is my initial state. I hope it is visible. Yeah. P. P on 0 goes to PQ. P on 1 goes to itself P. Next Q on 0 goes to R. So we don't have now Q state, so let me make it as here Q. So Q on 0 goes to R, right? Next, R on 0 goes to S. This is a final state, so I need a double circle. This is here S. So R on 0 goes to S, R on 1 goes nowhere. Next, S on 0 and 1 goes to itself, SS. Then PQ on 0 goes to PQ on 0 goes to PQR, right? Then PQ on 1 goes to PR. So again, there is no such states. Where should I make? Okay, 1 goes to PQ on 1 goes to PR. Next, PR on 0 goes to PS. PR on 0 goes to PS. Since S is included, this will be a final state, right? So PR on 0 goes to PS. PR on 1 goes to P. PR on 1 goes to P. Next, PS on 0 and 1 goes to itself. Next, QR on 0 goes to SR. Now there is no such state QR. So I need to make state as QR. So QR on 0 goes to S and QR on 1 goes to R. Right? Then PQR on 0 goes to PS and PQR on 1 goes to PR. Is it a diagram? I have just marked all the transition as per this table entry delta. Okay. Now what is your observation? Even though this is a minimized DFA, okay, you can see that QR and QS, this particular part, okay, is not reachable from initial state. Okay, that means you cannot go through this stage from initial state, and it is necessary whenever you are designing, constructing any NFA, DFA, any finite automata. It is necessary you should always start from initial state. But to reach to Q, you are not able to have connection. Okay, so this is your network break. All these are the unreachable states. Okay, so you will not include this in a final DFA. So final DFA will be having how many states? 1, 2, 3, 4, 5. So if you will nominate them as, so let me nominate this as, this P is your A, this is your A, then this is your B, then on 1 this is your C. I'm marking as it is in the book, okay, and this is your D, and this is your E. So final DFA will be having only these 5 states, and you can easily draw that the DFA as this. Okay, visible? Okay, so let us have two summation. It is 0, 1. So A, B, C, D, E, where A is initial state, E is your final state, right? And now make the entries. A on 0 goes to B, A on 1 goes to A, B on 0 goes to D, B on 1 goes to C, C on 0 goes to E, C on 1 goes to A, E on 0 goes to E, E on 1 goes to C, then, am I right? With D, D on 0 goes to E, and on 1 goes to C, E, E on 0 goes to itself, and 1 on itself. Okay, so you'll be having entry like this. Any equivalence you can find here? No. So this will be your final DFA. So you have to nominate all this inside it, and you can draw once again. So this is your minimized DFA. So in this example, you could have some equivalent states which you have minimized, and you could have the unreachable state, so you could minimize. There is no trap state. If it is there, then you have to also remove such states. So I hope this is clear to you. So it is expected